Let's start with one of the most underrated heroes. Despite his lack of superpowers, Hawkeye hits his targets with astonishing accuracy. While Jeremy Renner trained with Olympic archers, it would be wrong to compare Hawkeye to them. Athletes shoot at static targets while remaining stationary themselves. Clint, on the other hand, consistently hits moving targets while moving himself. Of course, some of Hawkeye's shots can only be explained by luck, but archers can indeed make seemingly impossible shots. In ancient times, many Eurasian cultures used a tactical maneuver known as the Parthian shot. When pursued by enemies, horse-mounted archers would turn 180 degrees and begin firing. Modern archers also retain this skill, and some can make their arrows curve around one or more obstacles. So we've covered the skill aspect, but how does Clint manage to penetrate robots with his arrows? He does it from a relatively close range, which means that the arrow's penetration speed isn't exceptionally high due to the lack of distance. In one experiment, it was found that shots from a longbow at 25 meters caused minimal damage to a 2.5 millimeter thick steel breastplate. It's worth noting that it takes 72 kilograms of force to draw such a longbow. Of course, Clint uses more modern bows and arrows. A mini-Ultron, like the Iron Man suit, is probably made of a mixture of titanium and gold, making it about 4 times stronger than steel, so Hawkeye would have to use a lot of force to pierce it. So this aspect is probably not realistic. Let's not stray too far from Tony and immediately discuss his most powerful suit, the one made of nanobots. If we were to examine the suit under high magnification, we would likely see a robotic lattice structure. It would probably be the size of a grain of sand, with each cell containing a microscopic computer, capable of calculating its trajectory relative to other cells and orienting itself in space. A single nanobot would not be of much use to the user, but their collective behavior could be beneficial. A real-world analogy can be found in certain types of ants, which use their bodies to form intricate structures. This behavior is explained by the communication between the ants and a decentralized nervous system. To control the nanobots, we could use wireless communication. It would help us direct the nanobots and give them specific shapes through gestures, but it would require immense computational power. The computational complexity would increase with the number of nanobots. But how would we control the shapes the robots take? Stark could very well use artificial intelligence to teach the nanobots to make certain shapes in response to certain gestures. It sounds great, but it is still a long way from reality. There are some rudimentary forms of robots that can autonomously assemble themselves into 2- and 3-dimensional structures. These robots are much larger than their movie counterparts. In a study conducted by Harvard University, 1,000 autonomous robots were shown forming various 2D shapes. Using a special algorithm, scientists were able to tell the robots to assemble into a star shape with a single message. It took them 12 hours to do so. Thanos would hardly wait that long to strike. But technically speaking, the technology that Tony uses in the movies already exists in the real world. Perhaps we can replicate a simpler superpower, like crawling on walls like a spider. To do this, we need to understand how real spiders crawl on walls. If you were to examine a spider's legs under a microscope, you would see clusters of tiny hairs. If you look closer, you can see triangular microscopic structures. These structures allow spiders to form intermolecular interactions with almost any surface, allowing them to adhere to it. Incidentally, like Spider-Man, spiders are adept at controlling their descent. In one study, researchers dropped tree-dwelling crab spiders from the canopy. They found that as they fell, the spiders extended their limbs forward in an attempt to land safely on the nearest tree. So if you're worried about a spider accidentally falling on your head while you're walking in the woods, don't worry. They're doing it on purpose. Geckos also have the ability to climb walls. They also have tufts of hair on their feet. But in addition to these hairs, geckos also use electrostatic forces. Can we use this knowledge to gain the ability to climb walls like Spider-Man? According to research, the gecko is the largest creature whose sticky pads can support its body weight. In order for a human to be able to cling to walls like Spider-Man, 40% of his body would have to be covered in setae. Of course, we cannot grow them, but perhaps ingenuity can save us. Elliot Hawks of Stanford University developed special gloves that allowed him to climb up a glass wall. So crawling on walls was figured out by wall-climbing gloves. Let's move on to another hero in a red and blue suit and consider how Cap could survive being frozen. The most dangerous effect of hypothermia is the formation of ice crystals. It damages the body by forming crystals and dehydrating cells. The leakage of water from the cells also leads to an increase in interstitial fluid, which disrupts the homeostatic balance of chemicals within the cells. These effects are irreversible and would have been the main obstacle to Cap's survival. In nature, many animals survive temperature drops through physiological changes. For example, wood frogs reduce the formation of ice in their cells by producing glucose in their livers. The influx of intercellular sugar limits the formation of ice between cells by occupying the available water. This mechanism allows the frogs to survive in freezing water. This strategy would make sense if Captain America's liver could store a supply of glucose for 70 years. Another method is to produce antifreeze proteins, as seen in Arctic fish. However, we doubt that Dr. Erskine used fish DNA to create the super soldier serum. Another way to combat hypothermia is hibernation, which is used by many mammals. They slow down their metabolism and reduce their breathing and heart rate. This allows them to conserve energy. In this case, Cap would have needed significant fat reserves. Since he didn't fly to his grandmother's house, this option is unlikely. In reality, however, there have been cases of people going into hibernation. One such case is that of Carolina Olsen, who mysteriously slept for 32 years. Perhaps there is a hidden superpower in all of us, and it is not unrealistic to call Cap's transformation a true miracle. Let's not overlook the villains, either. Let's discuss whether Ultron's plan to destroy humanity was well thought out. The Shakespearean evaluator planned to drop a fictional country called Sokovia on Earth. Based on rough calculations, the diameter of the portion of Sokovia lifted into the air by Ultron is estimated to be 2 kilometers, with the church in the center taking up 1 kilometer on each side. According to NASA's guide, the asteroid Geographos was similar in size. Its mass is about 4 trillion kilograms. The key to the continuation of the dinosaur extinction would be the speed at which the rock would have to fall to Earth. To achieve greater speed, it would have to be dropped from a tremendous height. It's all about the potential gravitational energy that the city accumulates as it rises. All that energy would be converted into kinetic energy when Ultron decides to drop the city. In the movie, the city rose to a height where, in Cap's words, it became difficult to breathe. Let's assume that this height is where the effects of altitude sickness set in. This means that the rock was about 2.5 kilometers above the ground when the descent began. If we ignore air resistance, which we definitely shouldn't, we can understand that the force of the fallen city would be about 50 megatons. This is equivalent to the power of the Tsar Bomba explosion, the most powerful explosion ever created by man. Considering that humanity still survived that explosion, Ultron wouldn't have had the desired effect at that level of power. Let's say Ultron needed 100,000 megatons of power to achieve his goal. In that case, he would either have to detach a significantly larger chunk of Earth or increase the lift height to 10,000 kilometers. Perhaps Thanos' plan to save the universe was better thought out. The motivation behind it, as shown in the movie, was the tragic history of his home planet, Titan. Thanos realized that if the population continued to grow, resources would quickly be depleted, leading to the demise of Titan's population. Could Thanos' snap solve the problem of resource scarcity on Earth? Let's see what happens next. We saw a small part of the aftermath in Infinity War. The destruction of half of Earth's population would lead to social upheaval. The disappearance of half of the drivers, pilots, and traffic control personnel would lead to additional deaths. Water filtration systems, food supplies, and nuclear power plants would also disappear. In addition, half of the doctors, firefighters, and farmers would be gone. If Thanos wiped out half of all living organisms, the bacteria in the human body would also be affected. They perform several useful functions, including digestion, distinguishing between good and bad bacteria, and fighting off pathogens. All of this would cause a massive wave of deaths, especially in densely populated areas of the world. This would leave about 3.8 billion people alive. That's about the same population as in 1970. In all likelihood, Earth's population would return to its original level within 50 years, rendering Thanos' plan useless. Even if it took twice as long for humanity to recover, it would still face the same problems as before the snap. Thank you for watching this video, and if you liked it, please consider subscribing.